Find the maximum area of a fenced-in rectangle if you have 30 meters of fence. State the dimensions. Okay, so how would this work? Let's try to imagine a fenced-in area. Maybe it's in your backyard, maybe it's at your local park, something like that. And it makes a rectangle. You have the width, right? Those are both the width, and you have the length. Those are both your lengths. How could we figure out what this maximum area would be? Right, so you only have 30 meters of fence, and you need to make this area as big as possible. Well, we can come up with some equations to help us, right? Like I could say that my length plus my length plus my width plus my width, so all these sides added together, is equal to your perimeter, right? What's the perimeter? Well, we said you have 30 meters of fence, so the perimeter is 30, right? And you can also simplify this a little bit. You could say that 2L plus 2W is equal to 30 meters, just like that. And then you could even factor this side. You could say 2 times L plus W is equal to 30. And actually, if you divide both sides by 2, you could say L plus W is equal to 15. So this is the most simplified version of this equation that we could make. You could leave it in any of these other forms, but this is really going to make things easier for us if you write it like this. Now, what do we know about the area of the rectangle? Well, we know that the area of a rectangle is maximized if it's a square. Okay, like if you have 30 meters of fence, yeah, you could make it long and skinny, right? You could make it like 14, 14, 1, 1. That could be the distribution of your lengths. But that would only give you an area of 14 times 1, which is 14 meters squared. But if you decide to make it a square, so nice and big like this, that area is going to be much larger. So the maximum area of a rectangle occurs when that rectangle is actually a square. Because remember, a square is a type of rectangle, right? It's got 4 sides, all at 90 degrees, just like that. So if all the sides are the same, what that means is that your length is equal to your width, right? If all the sides are the same. So if length and width are equal to each other, that's another equation we have. I can plug that into this one, right? Using our substitution. So instead of L plus W equals 15, I could say, well, if L is equal to W, then really what I have here is W plus W equals 15, or 2W equals 15. Divide both sides by 2, W equals 7.5 meters. And if W is 7.5 meters, W is equal to L, that means L is also equal to 7.5 meters. So we know the dimensions. The dimensions are going to be 7.5 by 7.5. You can label that here. 7.5 by 7.5. Now what's the area of this going to be? Well, the area, you just multiply those together, right? So I'll write it here. Your area is equal to 7.5 times 7.5. So your area is equal to 56.25 meters squared. So your answer for the maximum area possible is going to be 56.25 meters squared if you made it a square. So see how if you make it long and skinny, you get a small area like this, but if you make it into a square, you get a very large area? That's because the square maximizes the area you can make with a particular perimeter. So keep that rule in the back of your head. That's a good thing to remember. Okay, let's do another one. For this question, we're told that we have to find the minimum perimeter of a rectangle with an area of 100 square meters. So this question is sort of the opposite of the last one, where now we're trying to find the minimum perimeter of a rectangle that has an area of 100 square meters. So let's think about it. There are different ways you can make a rectangle with 100 square meters, right? You can make it long and skinny like this, where this side's 100, this side's 100, this side's 1, this side's 1, right? Your area, 100 times 1, gives you 100 meters squared, just like you want. But what's the perimeter of this? Well, the perimeter would be 100 plus 100 plus 1 plus 1. Add those together, you get 202 meters. So I want the smallest perimeter possible of a rectangle that has this area. So let's try some other shapes, right? Some other rectangles that maybe give us different answers for the perimeter that are smaller. If you have something like this, so a little bit more boxy than the last one, maybe you have like 20, 20, 5, 5, something like that. The area is still 100 meters squared, right? Because 20 times 5 is 100. But what's the perimeter of this one? Well, 20 plus 20 is 40, plus 5 is 50. So the area is getting smaller the shorter we make this thing, right? The more boxy it gets, the smaller the perimeter is for the same area, right? because these areas are the same, but the perimeter got smaller. So what if we make it even more boxy? What if we just make it a perfect square? So these sides are all the same. So you would say 10 meters by 10 meters, right? 10 and 10. Your area is still 100, right? Still 100 meters square because 10 times 10 is 100. But what would your perimeter be for this one? 10 plus 10 plus 10 plus 10? That's just 40 meters. So in fact, the minimum perimeter is going to occur when you have a square. Once again, just like the last question. So this is your minimum perimeter. So the minimum perimeter of a rectangle for a particular area occurs when you have a square. So really you can think of it this way. When you have a square, that gives you the biggest area possible for the smallest perimeter possible. If you want the opposite of that, if you want the biggest perimeter possible or the smallest area possible, you want something long and skinny like this, right? It doesn't have to be 100 to 1, it can be like 1,000 to 0.1, right? You can start getting to decimals, and really because you can start making these numbers smaller, there's really no limit on how skinny and long this can be, right? So we tend not to think about it that way because it's not really practical, right? Usually what you want to do is make a fenced-in area like this with the maximum area, right? So most of the time we're talking about a square in these types of questions.